Here we're going to talk about similarity in right triangles, which is finding the altitude in right triangles related to similarity. So if you draw an altitude in a right triangle from the 90-degree angle, you get three similar right triangles. So if you draw in your altitude is CD. So then CD is your altitude. Altitude is the height of the triangle. You get similar triangles. And the key here is noticing that CD, the altitude, represents the long leg in the small triangle, and it represents the short also in the medium-sized triangle. Which brings us to geometric mean. Proportions in which the means are equal occur frequently in geometry. So for any two positive numbers a and b, the mean is geometric mean of a and b is the positive number of x, such that a over x equals x over b. It's easy to find geometric mean. It's just cross multiply and use your square root property. So basically you have AB equals x squared, x equals the square root of AB. And we take the positive side because we're talking about geometry. We won't take negative because we won't have negative distance. So that's geometric mean. So if I want to know the geometric mean of 6 and 15, so it's 6 over x equals x over 15. So I have x squared equals 6 times 15 is 90. Take the square root of both sides. I have x equals the square root of 90, which is 3 root 10. Or if you want an estimation, it's about 9.486. And that's geometric mean. So geometric mean for example number 2, 4 over x equals x over 18. So x squared equals 4 times 18, 72. Take the square root of 72, and you get x equals 6 root 2, or about 8.485. Next you have the two triangles, again asking where the geometric mean shows up in the similar right triangles. It shows up right here in SP because you have SP and SP. So we have SP and the small, which is the long, is getting compared to SR. So, and then SP and the other one is getting compared to QS. So right here, geometric mean is SP. So key here, you have geometric means and similar right triangles. So you have AD over CD, which is going to be the same as CD over DB, and vice versa, because you also can compare them to the bigger triangle. AB over AC and AC over AD, AB over CB, CB over DB. So let's put it to use. So we want to solve for x and y. So here we go. We're going to solve for x. You have to notice that here's the altitude. So that's going to get compared twice. We're going to use x twice. So we have x x. So this x value is getting compared to it is now, you have to be careful, is it in the medium triangle or is it in the small triangle? This is where I'm going to draw my triangles out. So I have my small triangle, this is x, this is 40. I'm going to draw out the small one, bring in my 90, this is y, this is 10, and then I have my big triangle. So my big triangle, where this is y and this is 50. So, and this is x. So there are my three triangles. Now I need to solve. So I'm going to pick the triangle that has both x's in them. So I'm going to be using triangle 1 and triangle 2. So I know that the 40 gets compared to the x, and the x gets compared to 10. So I have x squared equals 400, and the square root of 400 is 20. So x equals 20. To solve for y, I'm going to pick the two triangles that have y. So I know that in triangles 2 and 3, I know the 50 gets compared to y, and y gets compared to 10. So I have y squared equals 500, and the square root of 500 is y equals 10 root 5, which is about 22.36. So there's example 1. I'll do example 2 on a different slide. Again, draw out your triangles. It's going to make stuff a lot easier. So solve for x and y. I'm going to draw out my triangles. So I have the length of here is 25x. I have my short triangle, which is x, 4, y. Then I have my y, 21. So solving for x, I'm going to use triangles 1 and 2. I'm using triangles 1 and 2 because they both have x and x. So I know that the 25 gets compared to x because they're both the hypotenuse, and the x gets compared to 4. So I have x squared equals 100, x equals 10. Now in order to solve for the y, I'm using now triangles 1 and 2. So using triangles 1 and 2, I know that the 4 gets compared to y, and the y gets compared to 21. So I have y squared equals 4 times 21, which is 84. And the square root of 84 is 2 root 21, which is approximately 9.16. And there's example 2. So key here for similar right triangles, draw out your triangles, pick out the two triangles that share the same variable, and set up your proportions. So when you cross multiply, you're going to have x times x, or that variable times itself to get x squared. Then you're going to have to isolate. If you have any questions, shoot me an email. I'll be glad to answer it. Or ask me before school, after school.